Hey Year 12s, this is a video to talk about the absolute value functions and hybrid functions. First we will have a look at hybrid functions. A hybrid function is when there are different rules or functions over different areas of the domain. This is used to model real-life situations, where it is too difficult to find the one function to model all of the data. Hybrid functions appear like this. In order to sketch this graph, we need to break it down into the separate domains and draw the function between their endpoints. We know that as x goes to negative infinity, x minus 1 goes to negative infinity with a gradient of 1, and at 0, the function equals negative 1. At 0, the function x squared minus 1 equals negative 1 and goes to 0 at x equals 1. Negative x plus 1 then starts at 0 and goes to negative infinity with a gradient of negative 1. Sketch these in, and you have the following. Now we will look at the absolute value function. The absolute value, also known as the modulus, is used to define a number that is always positive. It can be shown as a hybrid function, such as this. Absolute value of x means that for every positive value of x, the function just equals x and is always positive. For every negative value of x, the function equals negative x, and due to the double negative, will now be positive. Absolute value functions have a number of properties which are important to know. However, they are fairly intuitive. The absolute value of two numbers which have been multiplied together is the same as the absolute value of the two numbers which are then multiplied together. This is intuitive since the value of the underlying numbers in multiplication doesn't depend on the sign, and both ways would convert a negative to a positive. The absolute value of two numbers which have been divided by each other is the same as the absolute value of the two numbers which are then divided together. This is intuitive for the same reason as multiplication. The absolute value of two numbers which have been added together is less than or equal to the absolute value of the two numbers which are then added together. This is because a and b could have different signs to each other, which would give a smaller number than the absolute value or positive values of the two numbers added together. Let's have a look at a practice question of an absolute value function over a specified domain. Question 5a from the first exam of 2012. This asks us to sketch this graph and to label the axes, intercepts and endpoints of the graph. First we can work out the endpoints of the function, which will give us the y-intercept as well. We do this by substitution, as seen behind me. We know that whatever we take as the absolute value in this function, x minus 3 will always be negative due to the sign out the front. Therefore, the function will decrease as the value of x moves away from 3, with the maximum occurring when x equals 3 and the absolute value is 0 and the function equals 2. We also know that the function has a gradient of 1, so it is now fairly easy to draw. We could also choose to draw this function by separating it into a hybrid, like so. Here we separate out the function so that whatever it would have a negative value, for example, at values of x that are less than 3, we add a negative sign to make it positive. However, in this example, the negative sign cancels out the other negative sign to make a positive. For values of x greater than 3, there doesn't need to be a change to the sign, therefore they remain the same. It is important to understand how to draw our basic functions, as once we start introducing more complicated concepts such as absolute values, we need to know our basics. Until next time, happy studying!